Let's take a look at the lesson, Changing Repeating Decimals to Fractions. This is Lesson 7 in 7th grade Accelerated Unit 1. When will you teach this lesson? Let's take a look at the big picture to find out. You can see that Unit 1 is coded in pink. So all these lessons will be taught in 7th grade Accelerated Unit 1, and that this is the 7th lesson in this unit. Which standards does this lesson address? Where can you find helpful teacher tips? And what about those presentation strategies? You can find all this and more in your scope and sequence for each lesson. First, let's take a look at the standard. Once again, you can tell that this is an Accelerated Math 7 standard, 10B. We're going to convert decimal expansions that repeat into a pattern into a rational number. So we're changing the decimals to fractions for those repeating decimals. Here's some helpful teacher tips. Also, the materials needed for this, decimals as fractions, this is the worksheet itself, the lesson itself. Okay, for presentation strategies, what this video is going to focus on is how to help kids discover this pattern on their own. So the students will be familiar with the pattern for terminating decimals, and there's some examples listed here. So the first sheet in this lesson will be a review, whereas the pattern for repeating decimals, this will be new information for those students. Now, just as for those of you that have never taught this content before, the pattern, as you can see, is that if there's a single digit that repeats, then that single digit will be placed over a single 9 in the denominator. 2 digits that repeat, 2 digits go in the numerator, 2 9s go in the denominator. 3 digits repeat over 3 9s, and so forth. So this is the pattern that we want the students to discover, but we definitely do not want to give them the pattern up front, because at that point, their thinking and their wonder will cease, and they'll just see the pattern and they won't understand why or even wonder why it works. So there's a pattern, we know, but why does it work? So we're going to take this example of 0.5, and this is something I would work in front of my students and just take any single digit repeating and change it, say that we're going to change it to a fraction. Now we do this by solving this algebraically, because before you know the pattern, you have to have seen it algebraically. So in order to find the pattern, we're going to have to do some algebraic magic. And so what we want to do is focus on the example that we're given, and we're going to set that number equal to x. So x for this problem will be equal to 0.5 repeating. And then in order to have an equation to work out, we're also going to need another fact. And the other fact that we're going to need is that 10x is equal to 5.5. Now, before you move on, you want to make sure that your students fully understand why this is okay. Because if they don't buy into this, they won't understand where everything else comes from after this point. So we're going to start with 10x is equal to 5.5 repeating. We can say that these are equal because we already decided that when we multiply both sides by 10, this is what we get. So these two values are equal. Now, the next step might be a little different for the kiddos, because they're used to seeing subtraction of the same thing on both sides. However, we are subtracting the same value on both sides. So what I'm going to do is I have 10x. I'm going to subtract x. On this side, 5.5 repeating, I'm going to subtract 0.5 repeating, because x, we already know right here, that's what x is equal to. So the value of this item on both sides is the same. Now, when I subtract this, 10x minus x, I get 9x. 5.5 repeating minus 0.5 repeating, I get 5 because these go away. And I'm just left with this single number 5 here. That's where that came from. And then I do a one-step equation to divide both sides by 9. So I end up with x equals 5/9. Now let them soak that in there for a minute. Let them soak it in, ask questions. And then my next step in the classroom would be to select another single-digit repeating number. Side by side. Don't make it difficult. There's no tricks. We don't want any tricks. We want them to look for the pattern and be able to understand and just be able to follow this equation. Now, in the classroom, I would not have them write this down. I want them to focus on looking for patterns, answering questions, and not just trying to keep up with what I'm writing. Because in the end, they're going to use the pattern anyway. They're not going to use these equations in order to find that fraction. So the next step, once again, would be to do another example of a single-digit repeating number. After that's complete, and they start seeing the pattern, then I would offer them a third single-digit number that repeats and ask them if they can offer, without working it out, if they could share what they think that the solution would be. And you want to do that until everyone is comfortable with the one digit that repeats. Okay, but y'all know there's more. This is not all. So what about when we have two numbers that repeat? What about 0.15 where both the 1 and the 5 repeat? If I follow my same method from the previous problem, I get 0.15 for x. 10x would give me 1.5 repeating, which we know this is not the same because what should really go past this? There should be another 1 and then a 5 and so forth. So now, take a look at this. I bring this down, 10x, and like I said, I should have had a 1 right there. When I subtract this though, the 10x minus x gives me 9x. This is the problem. We can't subtract when these two don't match up. So this is not a valid method for solving this problem algebraically. Take 2. Now, so this is the problem from before where we said it just didn't work out. So when two numbers repeat, we're going to tell the students that we're going to have to go out, and 10x did not work. We got to go out to 100. We're going to multiply so we can move that decimal over one more time. And you see that when I do that, what comes after the decimal for the 100x and what comes after the decimal for x, these match up. So now I'm going to be able to solve my equation. 100x is equal to 15.15 repeating minus x minus 0.15 repeating. Once again, these two equal. They are equal amounts, even though it doesn't look like the same thing. We know that these two are equal amounts, so it's okay to do this in this equation. The 0.15's repeating cancel out. This 15 will come down. We divide both sides by 99, and you could simplify that. So once again, this would not be the only equation. I would do another equation, have them give you an example, work it out the same way, side by side. They're looking for those patterns. You want them to see those patterns and offer answers as you work out. Once again, I would not recommend that they copy these examples down because this is not how they're going to solve. Eventually, they're going to look just for those patterns. So that's what I want them focused on while I'm working it out. And then give them another example and ask them to offer a solution without solving it algebraically. Okay, now one thing that we want them to do is we want to extend patterns. So they know how to do a 1-digit repeating, they know how to do a 2-digit repeating. So we want to ask them, what about when 3 numbers repeat? Now what's great about this is we can have the students test their hypothesis on the calculator. So once they have an idea in their head, then they can try and enter that in their calculator, and they can do this over and over for several different examples that you might give them until they're sure about this answer. Okay, so as a wrap up, the standard is about recognizing those patterns and converting repeating decimals to fractions. And once again, when I teach this lesson, I model the algebraic method for my students, and throughout my examples, we look for those patterns and discover the patterns of the nines.